Hi, I'm Andy and this is question 4 on the AQA Core 4 paper from June 2014. For more questions on this paper, click the eye in the top right corner. In question 4, we're told a painting was valued on the 1st of April 2001 at £5,000, and the value of the painting is modelled by V equals AP to the power T, where V is the value T years after 1st of April 2001. In part A, we need to just write down the value of A. So in order to find out the value of A, we're going to use the fact that when T is 0, that's on the 1st of April 2001, we know the value equals 5,000. And if we substitute those values in, we get 5,000 equals A multiplied by P to the power 0. Anything to the power 0 is 1, so we get A equals 5,000. In part B, it says, according to the model, the value of the painting on the 1st of April 2011 was £25,000. And in using this model, we need to show that P to the power 10 equals 5. Well, on the 1st of April 2011, the value of T will be 10. So now that we know A, first of all, we can put that in. So we get 5,000 P to the power T. And when T equals 10, we know the value is 25,000. So if we sub those values in, we get 25,000 equals 5,000 multiplied by P to the power 10. And 25,000 divided by 5,000 is 5, so we get 5 equals P to the power 10. In part 2, we need to use logarithms to find the year in which the painting will be valued at £75,000. So we're interested in finding the value of T when V equals £75,000. Now we could solve this for P and put it in there, but that would make it more complicated than we need to. In this case, I'm just going to set 75,000 equal to 5,000 P to the power T. 5,000 goes into 75,000 15 times, so we end up with 15 equals P to the power T. Taking logs of both sides, we end up with log 15 equals log P to the T, and using the power law to bring the T outside the log, we end up with log 15 equals T log P. Rearranging this gives us T equals log 15 over log P. Now to find the value of log P, we can use this expression up here. We know that 5 equals P to the power 10. Taking logs of both sides gives us log 5 equals 10 log P. I've used the power law there in the same step. And so log P equals a tenth of log 5. So we can say that T equals log 15 divided by tenth of log 5. Putting that into my calculator gives me T equals 16.8. But we still need to interpret that in terms of what year it is. Well, if we look at the question, it says T is the number of years after the 1st of April 2001. So if we add 16 years in, that will get us to the 1st of April 2017. But we've also got 0.8 of a year. Now if I do 0.8 times 12 months, then I know that that is more than 9 months. And if you count up from the 1st of April to the 1st of January, you'll see that there are only 9 months. So the extra 0.8 bit will actually take us over into the next year. So the year is 2018. In part C, we're told a painting by another artist was valued at £2,500 on the 1st of April 1991. Notice that this time here is 10 years before the start time for the other painting, and that's given by W equals 2,500 Q to the power T. And we need to show that according to the two models, the values of the two paintings will be the same T years after the 1st of April 1991. So notice here that T is the number of years after 1991. That means for our original equation here, we're going to have to modify that slightly to make it valid from 1991. So if we know that V equals 5,000 p to the power t from 2001, we can adjust this to make it valid from 1991. And if you think about it, if we're doing the time from 1991, then when t equals 10 for this equation, we should get the same value as if t is 0 in this equation. So it's been shifted by 10. So we can write that as 5,000 p to the power of t minus 10. It's easier to check that that's right than think it up in the first place. So imagine we put 10 into here for this one. That would give us p to the power 0, which would give us the same value as if we put 0 in here from 2001. So this is one of our equations from 1991. The other one is 2,500 q to the power t, and that is also from 1991. So if we want to find the time where the paintings have equal value, we just need to set these two equations equal to each other. But remember, that occurs at a time where lowercase t equals capital T. So we get 5,000 multiplied by p to the power capital T minus 10 equals 2,500 q to the power capital T. Dividing through by 5,000 gives me p to the power t minus 10 equals a half q to the power t. From here we can take logs of both sides. But at this stage, on the right hand side, we need to be careful, because you can't just use the power law to bring the t outside of this log, because the t is only attached to the q and not to the whole expression. What we can do first though is separate this out into two expressions, so we get log a half plus log q to the power t. On the left hand side we can bring the t minus 10 outside the bracket, because that's just applied to the p. And now that we've done that, we can bring the t outside of the log q to the power t. From here, in order to isolate t on its own, I'm going to try and get all of the terms with a t in them on the left hand side. Expanding out this bracket gives me t log p minus 10 log p. And then moving a few terms about, I'll move the t log q onto the left hand side. And I'll move the 10 log p onto the right hand side. And then I can factorise the left hand side to get t bracket log p minus log q. And on the right hand side I'm going to put this 10 back inside the power up here, so I get log a half plus log p to the power 10. On the left hand side I can combine these two logs as well to make another log, so I get t of log p over q, and my answer is now starting to look like what I want it to for the final answer. And on the right hand side here I'm going to keep the log half, but I found an expression that's equal to p to the power 10, and that's up here. Look, I showed it in part 1 that 5 equals p to the power 10, so I can write this as plus log 5. So I'll do the final two steps in one go. First of all, I'm going to combine these into one log, so I'm going to use 5 times a half is 5 over 2, so that gives me log 5 over 2. And then I'm going to divide through by this log, and we get the expression that we require. In the final part of the question, it says, given that p equals 1.029q, find the year in which the paintings will have the same value. So subbing that value into here, I get t equals log 5 over 2 over the log of 1.029q over q. That's going to simplify to log of 5 over 2 divided by log of 1.029. And that gives me t equals 32.05, which means that the year is going to be 1991 plus 32. There's not enough to get it to the next year this time. That's going to be 2023.